I'm Rory Cooper. I'm your moderator today. I guess maybe officially really Dr. Rory Cooper. I'm also a Paralympian. I'm an engineer by training, and I'm on the International Paralympic Committee Science and Technology Working Group. And today, this is our first session of the online version of VISTA, uh, the scientific conference for the International Paralympic Committee. Today with me, we have three distinguished panelists. I'll let them each introduce them individually, but we have Alina Blau, Dr. Ian Rice, and Marina Daftian. I'm sorry about that, Marina. And from the United States, from the Netherlands, and from Armenia. So maybe since Alina's up in my top left-hand corner, we'll let her start.
Yes, of course, I'll start. So yeah, I'm Elina Blau from the Netherlands, and I'm a human movement scientist with a background in physiotherapy. And I currently coordinate a collaboration that we call Paralympic Science Support NL. And in this role, we connect universities and universities of applied sciences with the Dutch Paralympic program. So we're really focusing on collecting questions and research needs from those programs and try to find answers by working together with academia, looking at existing evidence and conducting new research. So I'm very happy to be here today and be one of the panelists.
Thank you, Alina. Ian, would you like to go next?
Sure, thanks, Dr. Cooper. Yeah, my name is Ian Rice. I'm an associate professor at the University of Illinois in Urbana-Champaign. I've been studying wheelchair-using populations for years, biomechanic principles. I'm also an occupational therapist in background and a two-time Paralympian in wheelchair racing. So I've always included or been keenly interested in adapted sport to understand injury prevention, performance optimization. So thank you for being here.
Marina?
Hi, I'm Marina, a medical doctor from Armenia. I built my first company in prosthetics, upper limb prosthetics, and my background is in family medicine and rehabilitation, but I started my journey in science, working with myoelectric controlled prosthetics, and now we're building a remote patient monitoring tool for prosthetic and wheelchair users, which has a sensor technology. Yeah, and for adaptive sports, I believe the biggest opportunity is to understand more data as possible, so we can create systems that really work for athletes. And yeah, happy to be here today.
Well, thank you all. For you in the audience or listen to this later recording, this session is being recorded and will be posted on our VISTA website, the same website you went to register for the conference. And the abstracts are posted there as well from the individuals who submitted and had their abstracts accepted to VISTA. And there are video recordings of some of the abstracts, and we will continue to post those video recordings as we receive them. So at this time, I'd like to get started. As our panelists know, I'm kind of excited about the application of kirigami design. Kirigami being the cutting and folding of engineering materials to create affordable, high-quality adaptive sports equipment. I think it shows a real promise for creating lightweight conforming structures from a single sheet of material and making it more repairable and affordable. So Ian, either about kirigami or other areas, what are some of the most exciting near-term applications for adaptive sports equipment? And what are some of the biggest barriers to innovations in affordable and accessibility at scale?
Yeah, thanks, Dr. Cooper. I think equipment selection and optimization for the person's needs, the person's body structure, is key. And, to your point, Kirigami offers enormous opportunity. And to Marina's point, data collection, right? So we need to conduct trials with different Kirigami applications, which we're doing, right? We've had some between the University of Pittsburgh and University of Illinois. We've examined things like a Kirigami rugby wheelchair, a Nordic skiing rugby chair, tennis rugby chair, plans for a racing rugby chair, right? But it's important and critical that athletes, of all abilities, use this equipment. We compare it with existing equipment. So there's amazing potential, but like any new technology, there are challenges that need to be worked out and just discoveries that need to be made in terms of building infrastructure. What's the best way? What's the best assembly method, right? The most efficient, cost-effective assembly method may not be the most robust long-term solution. We just don't know yet. So there's all of this potential for cost savings and customization and efficiency. But there are just, various kind of nuts and bolts challenges to work out along the way, I believe. So yeah, finding ways of scaling Kirigami and building to scale that makes sense for all parties is something we're working on.
Great. Well, you were a rugby player yourself as well, right? And so,
Yeah.
so you,
Rugby is. I'm sorry. Go ahead. Yeah.
go ahead.
Yeah, no, I mean rugby is, a unique sport that's there's a lot of contact. The equipment required, must be robust and it must last. It's designed for contact. So this presents unique challenges. Kirigami or no Kirigami, right? So there may be a scenario where 90% of the chair is Kirigami and perhaps 10% are other parts or other combinations of parts. So these are things that we need to test. But so far, the rugby Kirigami chairs, they look amazing. They perform amazing. Um, but it really speaks to fit. It doesn't matter what you use if it doesn't fit the body correctly. It just kind of negates all of those benefits. We all know that. But Kirigami really has the potential to easily configure to a person's needs. So we saw that with the rugby, and there will be a publication out soon that describes this rugby Kirigami process, it was exciting.
Actually, I saw the publication came out last week, so people can find it online.
Excellent.
Great. Thank you. So, Alina, in your area of expertise and your experience, from a clinical and a rehabilitation perspective, what are some of the design features that matter most to athletes and coaches, and when evaluating a new piece of adaptive equipment to make sure it's truly usable and not just technically impressive?
Yes, thank you, Dr. Cooper, for this question. I mean, we all want to have a good design, but a good design doesn't mean that it's very innovative or technically elegant. It's defined by whether it works consistently, and that's what Ian already said as well. It needs to function under real performance conditions. It needs to not only work within a lab setting, but remains reliable during high intensity and variable environments. So small instabilities or inconsistencies, an athlete feels them. So a change in stiffness or a change in response over time has an impact on an athlete's um, performance and the safety within parasports. So I do think that one of the most important features is that it's comfortable and an athlete feels safe. So in order to really use the equipment, the athlete needs to think this is the equipment that I want to use and it really works for me. And then you also have the point of durability and maintenance. So that, in my perspective, comes after an athlete thinks it fits right for them and it suits their disability and they feel safe with it. And I do think that one of these innovations within a Kirigami inspired design, when it is low cost and it's it's easy to scale, it can really be beneficial when it comes to grassroots sports and really trying to get athletes that are a little bit into their talent development phase. We can really see if there's more people that can improve their performance by just having a cheaper, a low cost wheelchair that fits them perfectly. So I'm really enthusiastic about this this type of design. Yeah.
Thank you. So I'm gonna, if I can follow up both on Ian and Alina, that I know that also part of the problem is that sometimes athletes will take uh, sacrifice comfort or even risk of injury for performance, and so they wind up with uh, abrasions or bruises or sometimes even wounds. So, have any thoughts about how we can address that?
Sure. I mean, it's obviously not an easy answer, um, and it's hard to make generalizations. But if I were to, I think fit and fit, stability, security lends to an athlete feeling the ability to apply 100% of propulsive force, or fill in the blank, right? So when an athlete's in a racing chair and the tray is secure and the fit is correct and the dimensions are correct, it lends typically to an athlete not running into problems with ineffective propulsion or slips, falls, rubs. So I would say fit, and I think technology that informs fit can help accomplish that.
Yeah, I also do think it's the culture within a team, of the culture within the whole staff around one of the athletes. Because, of course, if you have this one big match that you're working towards, you might take some of the risk. But in the end, we all want long careers. So yeah, injuries do not help, and they will make sure you are not able to train for a long period of time. So I think education in what parts of being an athlete make you a real good athlete is one of the aspects as well. So it's not just only the performance, it's the whole mindset around it as well. And I think that's something we perhaps have to focus on a little bit more than just the performance part. But yeah, I do. Yeah, it's a challenge in trying to find the right balance of performance and safety and yeah, having a good comfort.
Marina, can you give us some thoughts on how you think data can help us both ensure athletes are safe and improve performance?
Yeah, so I agree with Fallon that sometimes we do some assumptions. For example, I can talk with my experience as a manufacturer. We do some assumptions that maybe some feature is needed based on the small, like episodic testing. But this is the main thing that can lead to design mistakes. Because it's not a real environment, it's the lab setting. And the main thing about collecting data is to make the data from the real world usage. And this is what we're working now. And this really can help to change how we're designing, how we're trying to make the systems really comfortable for the long-term use. And the main thing is to make this data also, the longitudinal data, natural, let's say, because, for example, what we have now, there are some manufacturers that they have their sensors, they have their apps, but this is very fragmented. So we don't have a space where we have all the data which we can use for AI insights to make really good results in research and development. This is why we're trying to now unify everyone in one place, because the fragmentation is not only about how we collect the data, but also how we interact with each other, each stakeholder, patients, clinics, manufacturers, researchers. I believe if we have a shared platform in which we can all be together, a neutral space, it will help a lot. The device agnostic data tool in which we will have all the insights. Yeah, this is the main points.
Great, thank you, Marina. So, wheelchair, orthotic, prosthetic, limb-mounted centers are generating rich streams of data of performance in both health. And so, Alina, what are some of the most meaningful metrics we should be capturing or trying to capture? And how do we translate that data into actual actionable insights for athletes and clinicians?
Yeah, again, a great question. I think we're at a point that we're no longer very much limited about data anymore, but it's more that we select the right data. And if we have collected that data, that we make sure we translate it into the right actions. And I think one of the key metrics for me is movement efficiency. So for wheelchair athletes, this, for instance, can include push frequency, push effectiveness, symmetry, acceleration patterns, or for prosthetic users, similar insight come from step symmetry, loading rates, and joint movement patterns. So the metrics that we should collect can really help us understand how efficient an athlete moves and not just how they move. And I think after that first key area, there's a second layer, which would be connecting the external load to the internal load. So also not only what the athlete does, but also how demanding is it for the body. So combining training volume, training intensity, and fatigue related indicators to help estimate the true training dose. So we can really aim for high individual variability because it depends for each individual. And then a next step would be the injury risk and early warning signals. Like Marina already said, longitudinal data can try to give us information about some spikes within workload or an increased asymmetry, for instance. So in my opinion, there are so many different metrics that could be really interesting. And I think one that's sometimes also forgotten is the daily life load, especially when we're working with our Paralympic athletes. We're really focusing on the load of our own training, but we tend to forget travel time, or we tend to forget how many transfers an athlete makes during a day, or how many stairs someone walks, someone climbs with their prosthetics. So that's also metric information that we should include into the full load of one of our athletes, and then try to collect it over time. And we should not forget, like, we're in this area of very much data driven, but we should not forget to ask our athlete for feedback as well, because sometimes there's a spike in the data which can be very easily explained by an athlete because of something that's happening in their individual life, or because there's some mental issues, or etc. etc. And sometimes an athlete is just in pain, or is just very tired. So it's very good to focus on a lot of those metrics involving movement efficiency or external and internal load, but we should never overlook our athletes. And ultimately, our goal is to create a shared language between an athlete, the coach, and a clinician, because we all have the same goal, and that's to improve our athletes.
Great. So how can how can engineers be more involved or engaged? How can we take this information and help this relate to new designs of either equipment, for the athletes' direct use or for athletes to be more informed?
Well, I mean, in the beginning, that what we as data scientists or engineers do is we try to come up with a solution that fits a question of an athlete. So we sometimes try to come up with very nice ideas, but in the end, it might not be something that that individual needs. So that's what we try to do within our daily basis. What I'm working on every day is that we really try to come up with innovations or engineering technologies once we have a question from practice, and not the other way around, that we design something and then we're trying to find someone who's willing to use it. So an athlete or an individual or an end user should be there from the beginning and should always be asked for feedback within this whole process.
Great, thank you very much. So, Marina, with your work at Connectra on longitudinal data infrastructure, um, what are some of the biggest gaps in how wearable and device-mounted sensors data are currently collected, shared, and used across the assistive device ecosystem?
Yeah.
Oop. I think you froze for a moment, but Marina. All right, I'll go back to Alina while Marina comes back online. Um, so your Alina, your research has examined transfer biomechanics and other ergonomics of assistive technology use and adaptive sports use. Um, how do you see wearable sensor technology evolving to get a better or more full activity profile for users, both in sport and daily life?
Yeah, again, a quick questions. Well, just a few years ago, we only did measurements within labs, and now we're trying to do measurements on the field, and that's because of the development of our sensors. And the key question for me now remains is it's not can we measure it? We get data, but the question is how reliable is this data? And we're at the moment getting much better understanding in how many sensors we need on an individual if you want to do measurements outside of a lab setting to be valid. And if we take a sensor away, what does it do with our measurement error? And do we take that error for granted? So we get a better insight in what do we need in order to answer our question. And I think that's crucial because we want to capture the full activity of an individual, not only inside the lab, but outside also, because we want to know what the demands and what the load is on the individual. And we want to monitor them in the end just for 24 hours, just to see what they do in total in their life. And again, here it remains so important that with all the sensor data that we collect, we also have information about their fatigue, their pain, that also remains essential. So I do think it gets better and better. And then also the question is, how do we collect data on how an individual feels over these 24 hours? Because it's very easy to ask that question within a lab setting because you're there at that moment, at that time. But really having someone having a sense for 24 hours and then trying to figure out where some of the peaks are within the data, then it's very important in how we can match that data with the feeling of an individual. But I do think that developments are going towards a more complete, continuous, and contextual understanding of wheelchair users across life. And it here again depends also on how many numbers behind the comma do you want? What reliability do you take for granted? And again, that starts with your research question. And I think that remains the most important part, not just collecting data because of the collecting, but really starting with your question and then trying to find which sensor, how many sensors or which device would really try to help answer that question.
Great, thank you so much. Looks like Marina's dropped off again. Hopefully she'll be back shortly. This actually, Ian, I'll ask you a similar question. And
Sure.
at Illinois, you have, obviously training a number of world-class wheelchair racers as well as wheelchair basketball players. What sort of data do you focus on there?
Yeah. So, we're fortunate to have instrumented wheels from time to time, but what a scarce resource. And I wish that wasn't a resource that was so scarce. And before I talk more about some of the biomechanical variables, I wanted to dwell on the point about education and culture. It's important, I think, for a coach or an athlete to be sensitive to an athlete's everyday equipment, right? I've seen it over and over. The most accomplished athletes with the most amazing equipment and performance have very little knowledge of their everyday equipment and run into considerable secondary health complications because of their just lack of attention to wheels, cushions, skin, and forget about being taken out of the, participation. It may be a harsh opinion, but I feel like an athlete has no business competing if they're not keeping track of the day-to-day living tactics. It's important, and that was a culture at U of I that was impressed on us. But back to the biomechanical variables, it's difficult. I mean, there's only so much technology available. There's a real gap there. There's a real need. When we have instrumented wheels, we're certainly paying attention to forces and spatial temporal variables. But to Aline's point, it depends on the question and it depends on the atmosphere. Stroke count and peak force mean only so much without an important question coming before those variables. So, more technology is needed and questions need to be refined, I think.
Marina, welcome back.
So sorry, my connection is not very stable.
No, that's okay. We understand. Can we get back to the connection about the longitudinal data infrastructure and what some of the gaps are and what some of the opportunities are?
Yeah, so the gaps, as I already mentioned, is mainly because of the fragmentation. So we don't have any unified data collection methods, protocols. We don't have a unified space for everyone. And the thing is that we're not, sometimes we collect the data, but
Give Marina a chance to log back on and see if she gets a little more stable this time.
Sure.
Actually, we'll move on. We'll get back to Marina when she gets back on. So I'm going to move directions here a little bit. Now there's AI-enabled coaching and training systems, and they're being used more and more often. Ian, as a two-time Paralympian yourself, would you have wanted to use AI coaching system during your competitive career? What would you have felt intrusive, helpful?
Yeah, I think, it depends on the athlete and the system in which they're working with. If they're working with a coach and a team, In my day, I found myself, I was going to graduate school at the time. I would have loved AI, right? Because I found myself a little bit isolated. But I think, you know, I want to know what all elite athletes know. I want to know how to, you know, I want to know periodization training. I want to learn how to peak. I want it all based on empirical evidence. And any AI tool that could do that would be amazing. And how to use competitions to build up, right? How to use competitions not only for performance, but to, support that goal of periodization. That all of those elements were way over my head as an athlete, and I would have loved any help I could have received. I think in that arena.
Alina, what do you think about that today? You think AI is going to be a growing tool in training?
I mean, yes, I do think it can be a growing tool. However, I am still a little bit skeptical because I do think every individual is so different. And of course, AI tools generate it from a mean, and every disability is different, every body position is different. So yes, in general, the general training principles, they sometimes work, and I think you can really try to create a concept version of periodization or just a training schedule. But then again, you also still need to understand how everything works just in order to look back at it and really look at what the AI coaching tool has generated, to with your own common sense check if it's really suiting. So I do think it can be less time consuming with use of AI, but still we do need to have all the knowledge that we needed last year, we needed yesterday, and we're needing tomorrow. So I do want to be a little bit careful when it comes to people having this coach role, because I mean still we do need good education as well, but I do think it could save a lot of time.
It seems like you'd also want to be able to update it by entering your own data, right? So you enter your training and performance data, and ideally, collect uh, training and performance data from a large group of people. At least in parasport, we have individual classifications, and we know what events people are training for, and so you could possibly improve the AI training models by taking training data from all people of a similar classification in similar events, right? And sort of update it as well.
Yeah, I mean, in an ideal world, yes. But if I am that number one athlete, and I'm currently number one, I do not wish my data to be in that database. So I do think it would be very interesting to collect that information from grassroots sports or
Mhm.
a lower level. But I think with competition wise, I'm not so sure if every athlete allows their own data to be put into an AI tool like this. But it does help train the model, yes, for sure.
Yeah, although I guess in some ways the AI would give them some sort of anonymity, right? So your data would be in the model, but not necessarily individuals couldn't look at your particular data, right? Only how that they would only get the outcome of how it influenced the model. I think you brought up the grassroots question, I think is also interesting. If you collected grassroots performance data, training data, and classification data, you could theoretically look who might be an emerging athlete, right? Or identify athletes earlier in the process for advancing. Although I think there's a lot of different factors that affect the ability for somebody to be a world-class athlete and to compete at the Paralympic level. It's just, access to equipment and coaching and facilities, whether they have the talent, the desire, and in some ways where they lie on the classification scale. If they're sort of the least impaired within their classification or the most impaired within their classification, also has some impact as well. Then if classifications change too, so that it's all, and then of course how there's sort of factors that are hard to discern, which I know everybody liked, is like your susceptibility to injury or your especially sort of your fragility of your personal condition, right? And also ability to tolerate pain, other things like that that come in or that are really difficult to measure, collect data on.
Yeah, I do think like collecting data from grassroots would be very interesting to set certain benchmarks. So if you're this age and you're doing this sports, this is where you perhaps should be if you want to be one of those top athletes based on this retrospective studies that we, for instance, did. So I do think it can yeah, it can help with talent development. But yeah, then again, I'm not so sure. Even if you already look at classification research and not everybody wanting to enter the research because of their data being used and they're at their top level at the moment already and they want to stay there. But I do think the grassroots would be a very, very interesting topic.
You mentioned some of the risks of using AI, and that's that top athletes would not necessarily want to share their data so that other athletes can view it. I guess you could argue the same thing for athletes that think they're on the track to be the next world champion, but and so they don't necessarily want people to see what they're doing to get there, right? So it's a little, but uh, um, but can you think of some other potential challenges there might be as because I think it's sort of inevitable that there's probably athletes using AI right now to get coaching tips, perhaps based on their own data or even based on public results, right? So do you think, can either of you think of any challenges we might be able to face?
I can imagine, I mean, they're becoming a little bit of an endangered species, but athletes with autonomic limitations, right? So, how do we apply effort and training to athletes that essentially have different cardiovascular systems? And I think there are many unanswered questions there that it'll be pretty interesting to gather data around athletes, you know, like this.
Yeah,
Yeah,
there's,
no, yeah.
go
I
ahead, Alina.
agree on that part. I mean, the same also counts for like the cerebral palsy and their different severity of it. Like because we're all the athletes are so different. But and then again, I think if we would want to develop something like this, the AI tool, the AI coach would help point you into a right direction. I mean, it's not going to be a threshold. It's just going to be this range or this benchmark of where you perhaps should be. And of course, there's always the outliers. But if you see one of those outliers on the positive side, you perhaps want to keep that athlete and make sure it doesn't get an overuse injuries, for instance. Or if you have someone that's a little bit below that benchmark was almost there and that athlete's not sure if it wants to be a Paralympic athlete or not. I mean, it can help you, it can guide you into that athlete becoming the best their best self.
So actually, just to shift gears just a little bit, it seems to me like AI could be useful for the Paralympics or sports organizers themselves to know like what type of equipment or repair parts would you need to have on hand before an event, right? So some of the events that I help participate in or organize, that's always like how many tires do we need and how many basic nuts and bolts and what might break, different webbing, padding, strapping, all that sort of stuff that you could basically, if you collected that data over time of what's used for what type of event, for what type of athlete, you could actually start to predict and maybe do a better job of the logistics in the future as well. Right. Oh, looks we had Marina for a second, then we lost her again.
Yeah,
Uh,
so
let-
sorry. I
oh,
wanted to.
Go ahead then, Marina. We can, since you're back.
Yeah. So I wanted to add a point about AI and how it will affect motivation. Actually, the main thing that I believe we should use is based on their personalized data and behavioral data. As we said, it's not only about their training data, but also their daily life. And it matters a lot in terms of how they will train and how we can motivate them to become better athletes. The thing that we're doing with our models, we're gamifying a lot of part of their experiences, and based on their behavior, daily activities, and not only just training. Yeah, combining these both activities, I guess it's very crucial, and also building an interest towards Paralympics, and because there are a lot of people who have a potential to do that, but they are maybe the competition part is important, how we design that. That's why how we do it, it's based on the psychology. It does the competition are designed on two ways, based on personal progress and based on the other progress. In our app, we have a dashboard where they can see their personal progress based on their previous data, but also have see the scores of other participants, for example. And this is extremely different things that we use, like the techniques and the data that we use to gamify these two processes are completely different.
Very good. I think that's a great point, right? It's about, you can use data for about how your performance is doing, but also about your mood and how your mental health as well as physical health.
Yeah.
And then and also I would also curious, you know, as a retired from active competition athlete, I would say, you know, as about ability to stay engaged for a lifetime, just for your own personal physical and mental health is also important. So the sort of the post Paralympic athlete is also really important. We don't want to leave people physically or mentally broken afterwards as well, right?
Yeah, sure. Yeah, exactly.
So maybe we can change gears again. There's a lot of new tools for low-cost biomechanical analysis, especially smartphone-based motion capture devices like even like the Microsoft Connect or apps for your phone. Um, so I'll maybe start with Marina while you're still able to connect. Um, so what do you think about some of those devices, and um, what do you recommend as part of some of their uses?
Yeah, I believe that it depends on the goals. As I said, some tools are better for just general tracking, and some can help with the. I guess what we lack now is exactly on the long-term support. Many of the apps that are they are designed for particular training or particular experience, but there is no long-term support system which works better for like for long-term effect. This is the gap that I see right now. We have both on the available tools, manufacturer tools, or general physical mobility rehab. For example, physical mobility rehab tools or tracking tools are, I guess, very general. And again, we deal with the personalization issues there. While we have data, it's not personalized enough to have the better results for the athletes. But still, they can be useful. It depends how we use it in the particular settings. For example, we again have Strava, which is for athletes, but it can also be used for Paralympic athletes. And Strava has a good potential for the community part as well, which I think is very important for motivational part. Not only the data collection and sharing, but also sharing the experiences within peer community.
Great. So Elena, as a movement scientist, how do you see these low-cost biomechanical tools being integrated into practice and community sports programs? And what sort of
Yeah, I do.
training is needed?
Yeah, I do think that these low cost tools are a huge opportunity to democratize biomechanics, but only if we integrate it responsibly. I mean, using smartphone-based motion capture is different when it comes to a full Python, for instance, motion capture. So I think the real strength of smartphone-based motion capture is the accessibility and the scalability. So it allows us to measure outside of the lab into a training hall, sometimes even in the snow or while being in the water, which is not possible when you're really doing this lab-based testing. So it means more athletes more frequently can benefit from movement analysis instead of athletes in research settings. And I do see it used in practice. For instance, when it comes to being in the snow or when you are, for instance, on a surfboard, because it can give the coach a tool to quickly give feedback to their athletes, or use it as an educational tool. But I do think it's important that we understand that we're not trying to make coaches or clinicians become biomechanicalists. But they do need to understand the tool and especially what they cannot measure. So they need to know what they want to use it for and what that specific tool really can measure. And then if you want to know what you measure, you can look at the tools that are available, because they're not all the same and they have different errors. So we need to educate the coach or the clinician to really understand what the expected errors could be and how to interpret the trends instead of just single numbers. So I do think it lowers the threshold of doing biomechanic research, and it can help the athlete to improve, but we should never forget the real lab settings, because I do think that's of course still the golden standard, but it can make it more accessible, and I do see it being used within practice.
And even smartphones today, I mean, some of them have like laser rangefinders, not just a camera, but they might have a binocular camera, a laser rangefinder, and of course, a lot of phones have IMUs in them. So it could either be a biomechanical tool linked to either a camera that's stationary, linked to a person's camera that they're wearing, and that could collect additional data. I think there's a lot of work that's going on in robotics, especially mobile robotics, and so that we could apply those sensors in the future to have low cost sort of wearable, or either that or basically stationary biomechanical systems. So Ian, I assume you're using some of these things in Illinois as well, right? It's kind of natural, especially you've got a college student population of Paralympic athletes or parasport athletes, and so do you have any idea of how reliable or how valid these tools are, and where they might fall short or where they could be improved?
Yeah, it's a good question. And the Connect technology is only getting better and better, and it's exciting and it's low cost, but it's not as accurate. But it depends on the context. It could be, but generally speaking, the accuracy is lower. There's line of sight limitations sometimes, right? Where a full kinematic system is three-dimensional, right? You need to be right in front of the camera, but that's a limitation, but that could be okay depending on the application to the other points. Some of the kinetic systems or the Kinect systems are not as quick. That's okay too. So it just gets back to education, guidance, and the application that it's being used for, because it might be ideal. It certainly might be ideal, but it's certainly not ideal for everything. So you've just knowledge and guidance going in.
Very good. Yeah. And then I think Marina brought up an interesting point about some of these sort of connected training tools. So that I've used them myself, where you can participate in, in a wheelchair race or a hand cycle race with people around the world, right? And while you're doing that, you can collect your own speed and acceleration data. You collect your own heart rate. I guess theoretically VO2 max if you were wearing the right equipment, and the other athletes can as well. So I think that's an interesting way. Ian, like you, for part of your training for the Paralympics, you weren't at you didn't have you weren't at a large program where you could train with a lot of other people. I had a similar experience. I know that's in the United States that's true, but it's true a lot of probably in lower income countries as well, where athletes are not don't have access to as much competition or even the ability to train with other athletes. I think that might be another exciting. I think that's an exciting advancement, especially post pandemic, where those tools are made available for you could kind of test yourself on a world stage without leaving your own living room.
Absolutely. Yeah, the way the technology is developed is amazing. What's available now compared to what was available when we were athletes is it's so different. And athletes, even under ideal circumstances, yeah, they are coming together as groups, but there's significant downtime where an athlete might find themselves isolated or somewhat isolated, and any access or any bridge to that team dynamics could be helpful.
Yeah, as long as it steps in when there is a lack of social contact, but we always need to be careful for the other way around, when someone is not going to a group session anymore because he or she thinks they could rather stay at home. So I think we always have to be careful when it comes to virtual connections there, because like this real in-person social cohesion is so important for an individual as well. So yes, in some times it can be beneficial, but we also have to take into account the negative parts when we come up with new innovations and new solutions. So yeah.
That's great. So AI is starting to be used now to actually design devices, so do physical designs, where you can, even with our Kirigami, we use it sort of optimize the minimum amount of material to be used, and the folding efficiency, the cutting efficiency. But others are using it for like design entirely new concepts for prosthetic limbs or orthoses, especially in combination with the capability of 3D printers now. Combination of metal 3D printers, plastic 3D printers, composite 3D printers. And I think that's going to be influencing wheelchair and orthotic and prosthetic design as we go forward. So Ian, I know, can you think of some examples of this that are where are some of the more promising areas to do this type of work? And how close do you think some of these tools are?
Yeah, I think it's going to take time. I think we need to do a formal study which is focused not only on the build but the resources that we need to complete the build, right? The cost and the labor and the efficiency of obtaining these resources. And also, what materials lend best to us, for a particular application. Carbon fiber isn't always, or titanium isn't always ideal, right? It depends on the application and the knowledge of the build. Yeah, I think we're close. I think we're doing some of this now between the University of Pittsburgh and U of I, and I'm sure others. But it's going to take time for, these applications to come together and actually yield some data.
Great. So Marina, with your background forming arm biomechanics and now Connectra, so how important is real world longitudinal user data in closing feedback loops for device design?
Yeah, as already mentioned before, we were only using the episodic testing data, which was not that clear. And what we did with one of our patients, we designed this prosthetic arm for swimming for him, and we gave it for testing for a longer period. And we used trackers to understand the data, how much he's training, like how much his training speed is changing. And we also did interviews with him. So we used both the data and also behavioral data to understand.
Well, all right. Well, Eileen, while we wait for Marina to jump back in, is if we want to develop these AI design tools, what are some of the, from a usability standpoint, what do you think we have to get right for these product devices?
Yeah, I think that's a very important question. I mean, I hear what you and Ian say when it comes to cost efficiency, when it comes to using the right materials. I do think we need to keep recognizing that assistive devices are used for a diverse population with different impairments, different body proposition, different strength, movement strategies, etc. So this average user simply doesn't exist within practice. So what works well for one person might be suboptimal for another one. So I think with the rise of AI driven generative designs, the core principle for me remains that assistive technology is fundamentally individualized. But I do think AI can add a value by producing not a single optimal design, but by developing models that can predict expected movement patterns and expected mechanical demands based on individual characteristics. So such as type of impairment or leg length or body height or mass distribution, etc. So if AI can help us to improve those predictive models, and we can better simulate how a device will behave within real life and really use those models to try to come up with the best design that fits that person. And I do think we can generate a model like that that's general, but then add those specific individualized information metrics within there. So it allows us to then much more precise, make personalized design recommendations. And then afterwards, we still do need a clinical person to really try to see if it really fits or not. So I do think this AI can be used to do all those calculations when it comes to the best material, how to make it cost efficient. I really do think it would help us there. But then again, we try to find, we need to find these models to really make it individualized as possible. And then make it less time consuming to create those devices. So I think in the future, there's not this optimal design. I think there's this optimal method to come up with new designs. So, but I think it's really promising what we can do on long term. Yes, for sure.
I think you make a great point that all AT is fundamentally individualized. But I also think that you can use these tools, um, much like we did CAD, computer-aided design models, and then you use into build like parametric design where we could scale a design, and then you could basically, and even just the fact they have a CAD model, you can make modifications for an individual without having to physically build it. And you could go through basically different design iterations before you started building. But I also think I'm excited about is that there are more and more flexible manufacturing tools available where we can use, we have great and improving computer design tools, both for electronics as well as physical design. And then we have more flexible manufacturing where you can use things like computer numerically controlled laser cutters or even or CNC nuclear press brakes or milling machines or lathes that they don't have to make the same thing all the time, right? Because it's basically you upload the software and then it changes for each one of the softwares. Um, so I think that that helps with customization as well. And in some ways, it's um, it's kind of like a smartphone. The even though there's a variety of smartphones, but they're all highly customizable, right? I would be willing to bet that even if we all own the same smartphone, within a month or so, our smartphones would be custom to the individual. Um, and in some ways, you can think of that with computer-aided design as well, where you'd have a rugby chair. It's kind of a rugby chair based on the rules of rugby, but um, you know, each person's rugby chair is different, is customized for that individual with sort of within a generalized framework. And so I think that's where the advantage of where uh, better computerized tools. So I look at AI some way as the next generation of integrating with CAD CAM tools, computer design and manufacturing tools. For example, another challenge we have when you go to make these things, might have a great CAD model or computer design model, but you have to pick the tooling and the machines to use. And this is a great where AI could say, you can make it on this machine, or this machine. Based on the tooling you have, it would be faster and cheaper to make it on this one, or go from this machine to this machine to this machine, which those are often can take years, if not decades, for a person to learn those skills. Where I think different AI models could learn even the manufacturers could basically start to train those models. And so when you knew what combination of machines you had, what tooling you had, it can make manufacturing of AT much more flexible, much more uh, affordable, but also customizable for individuals in an affordable way.
Yeah. For sure. And another point is modular design, I guess, which will play a big role here, because the same way we can use different systems or programs, technologies, we can use the modular components to make it customized, but still have low manufacturing cost. Because every time we're talking about like full customization, the main thing that is a barrier right now is cost, because if we make every part like fully customized, it has a lot of challenges with it. But if we put it in a way that we have modular parts like Lego, and there are some parts that are same for some designs, for example the wheelchair frames, but some parts can be modular and changed based on the person's experience, even during the time. For example, as I brought the example of like swimming prosthetic arm, we changed during his training a lot based on his data, because when he started to train with that, we had completely different data after he trained like 2 months. And here AI can help a lot as well with the modularity.
No, I totally agree on that. Also, in an example, when it comes to talent development, if we have a young athlete within a customized chair, and the muscles develop further and further, and we can change the seating position of an athlete, if we can make quick adjustments without just trying to be put a cushion here or a cushion there or some tape here and there, but we can really change the chair in a modular way, we can make sure that the athlete doesn't need to buy a new chair each year because it improves. No, we can just adjust the chair, and it makes it more cost efficient. So totally agree on that part.
Actually, I'd like to follow up on both of those points. So one thing Ian mentioned earlier, when we do the Kirigami design, one of the things you can standardize, for example, is like, basically the bumpers on the rugby chairs are basically a standard component, right? And you don't need to customize those for each individual. So you could make those in larger quantities and then bolt them onto attach them to the chair. It'd also be nice because they'd be repairable. Right now, they're mostly welded in place. So if they were not welded in place, so you could replace that, could be a replaceable component. It could be standardized. It'd be easier to. Same thing like caster housings. The front casters or rear caster housings. Those are basically standard on all chairs, right? They don't need to be customized for each individual. And so those various components, and so we could, if you could standardize those, and then you could make other parts that need to be fitted carefully to the body, like other frame components, you can at least lower the cost of manufacturing. But I think, Elena, you brought up a point that's of great interest to me. It's not only the ability to grow, but the ability to repair. And so theoretically, they're kind of different sides of the same coin, right? You could, if you could take a good quality sports wheelchair that may not be the same level as you would use in the Paralympics, it may or may not. It was interesting to watch in Italy, the difference in quality of Paralympic athletes' equipment, even in the finals. But where you could maybe not, where you might have to go back to a mechanic, but they could like unbolt it or take rivets apart and then replace components to scale either with the growing body size or scale with the change in I guess sort of more body physiology and anatomy due to gaining strength and balance and flexibility that might occur with training or just occur in young people with as part of maturing, right? So I think that's an exciting sort of engineering technical challenge as well. It's like, can I if I'm adult and I'm not really changing, can I can the things come apart and be able to be repaired? But on the other side, maybe they could also be they could be altered due to they could be taken apart and then reassembled because of the change in performance.
Yeah, and if you even take it a step further, in certain sports, you perhaps can change the settings of your chair based on the type of play that you want to have. For instance, within the individual wheelchair tennis games, do you want to have a more knee-seated position, or do you want a more slightly leaning position based on your opponent, based on where you are within your tournament, the amount of energy you still have left? So just trying to adjust the situation best suited for you at that time, at that moment. So I
That's
think
an
there's
interesting concept.
a lot to win.
So on those, so that's kind of interesting because in some ways, it brings up another challenge in the Paralympics. It's that some athletes have more resources or access to more resources than others, and so they can have a highly customized carbon fiber um, wheelchair. Prosthetics, it's more common, right? That's prosthetics is already in some ways. Um, where they have used sort of a hybrid process, right, where there are standardized components like pylons and ankles and attachments to the socket, but all the sockets are highly customizable. And although of course, there are now sockets that were there adjustable as well, right? So they've got like 4 pieces of carbon fiber coming up, and then there's basically straps or belts that can sort of adjust them in different ways. And people are looking at different, and of course, in sports, people are looking at even 3D printed sockets that are used, like you said, maybe it's for you one socket for a sprint bicycle race, one for a longer distance bicycle race. You can trade them out. So mostly it seems like the 3D printed socket seems to be more efficient for the things where they're not as much load bearing as like running. That's a bit of a challenge. Although I know of engineers talking about making 3D printed feet that are basically disposable. So you only do 100 meters and then you throw your foot away, and the next 100 meters you replace your foot, or you can have a different foot for different track conditions or different weather conditions. So, um, but I think that's also creates an interesting design problem. How do you create technologies that are similar, that allow you to have similar performances, but not have if you don't have access to all those costs, you don't have the resources to buy that expensive equipment. Would be
Yeah,
interesting
that's
to have
true.
a modular racing chair in some ways, right?
Yeah. Coming back to 3D printing, like what we did, for example, about this little change during the process that we needed, we really adjusted a lot of small things, and the socket design as well were completely different for 2 patients, like for the same prosthetic, like swimming prosthetic arm, because of their experience. And this is the thing that we should always, this is actually debatable. We discussed it with prosthetic specialists, we discussed it with patients. It's very individual experience. Sometimes they, so we did a socket which is completely non-standard socket. Like I don't have photos right now to share, but there is like there is no standard model to doing sockets, and especially for adaptive sports, I guess the creativity is very important. We just worked with the patient, and he said like what he needs, and we designed it in a way that is comfortable for him. And 3D printing is a good way to do that, but still it requires some amount of work in the future to be able to make it more accessible for a lot of people.
No, I
Yeah.
I agree. Did you have something to say, Alina?
Yeah, I mean, I do. I mean, within innovations, within technologies, it's always the question on costs, and would it make a fair playing field when one has more money for development compared to others. But I do think like with the upcoming AI and with upcoming 3D printing, I do think like the whole idea of the innovation perhaps might be for the people, for the teams that have much more money available, but afterwards technology makes it so easy now to take over and try to copy what one country does for themselves. So I do think the more we're investing in kind of this modular wheelchair or adjustable parts, the better it would be in the end for all countries. Even though, because if we can adjust it over time, if we can adjust it on one specific moment in time without it being very time consuming, when it comes to other countries will have less money to spend. They could even share a chair, for instance, or replace some of the parts. So yes, it costs a lot of money to develop it, but once developed, I think the accessibility would increase tremendously, if you ask me.
I just wanted to mention wheelchair racing gloves, right, is a great 3D printing application, and lots of information circulating about that right now, and lots of opportunity. We've been working on a study at U of I with different materials for contact with racing, and it's something that could be a benefit to grassroots users as well, like what lends to a particular type of contact with a particular set of skills. So, and this is much more low cost, so pretty exciting.
Yeah, I mean the rigid gloves, right, originally started out with the backhand developed by this, the Swedish athletes with tetraplegia and wheelchair racing, and then was later adopted by the Gregor Golenbach and the Germans who came up with the original rigid gloves, and then Illinois went to the harness gloves, and then you could see right after as 3D printing came out, athletes quickly adapted that. You could buy a 3D printer in the United States even for a couple $100. It wouldn't make a glove that would last very long, but you can at least make one, get the shape, and then and the materials are getting, much more variety of materials, much better materials, just even than there was a year ago or 2 years ago. And the software is getting to be such that you don't have to be a highly skilled engineer or technician to use a 3D printer. You have, middle school or even primary school kids who are using 3D printers. I think what's also exciting about it, because they're digital files as well, right? They can be posted on the web and placed out there. As Ian knows, Ian and my team and Ian's team worked with John Duvall, who's collecting actually 3D printing ideas from throughout the world, and then also in determining what are the materials, what do the models look like, the computer design models, what machine was used, and posting that all on a website for free. And what's really exciting is you see people who are not only wheelchair racing, which is the example Ian gave, but for table tennis and for billiards and for bocce and it's an American sport. I guess it's growing worldwide. Cornhole, all these other sports where people just want to participate or compete on a local or regional or perhaps national level, and they make these sort of simple modifications, and then they could share ideas. I think that's another thing where you can get some both globalization and maybe even knowledge sharing in order to reduce costs and increase accessibility. Uh, as long as you have some form of internet access. It's also, I think, exciting. Some ways with 3D printing is that in some ways it's democratizing design a little bit, because even if you can't afford a 3D printer, there's likely that a school or a university somewhere not too far away has one, or even theoretically, if you do the CAD model, you could have it 3D printed anywhere in the world and mailed back to you. And so that's, I think, and so it'll be interesting to see how that further impacts um, para sports and adaptive sports. But I do think it's opening up. I mean, even for golf or mini golf, it's really interesting to see the things that people submit for ideas. either ideas they have or needs they have. I think the nice thing about that too, you can submit needs, and there are people who do have access to the CAD models or the talent or the 3D printing that they might just be willing to meet those needs just because they're interested to help and be involved.
I do think it's very interesting what your guys are doing when it comes to the 3D printing. I do a little bit, and I'm wondering how you guys are on that standpoint, but I'm a little bit nervous about people just 3D printing everything they want to use when it comes to using it into their daily life, when it comes to injury risk or risk of breaking or risk of failure, and when it comes to insurance. So as long as it is a device that is for low risk needs, I think it's very, very interesting. But how is your point of view then on the risk of it failing?
That's why we're trying to create a site that it's vetted. So all of the devices that are on there have gone through some engineering testing. And then all that data is included on the website. So it tells you this is the materials that we use, this is the design model that was used, this is the materials used, this is the type of machine used, these are the settings used, this is how it was tested. And so, and then this was the performance we got. There's still you're still making it yourself, so you are still liable. But the idea was to minimize the risk by instead of just saying, "Hey, I made this thing" or whatever, or then you is trying to at least explain not only what it is, but the process that went through to make it to try to standardize that process.
Yeah,
But at
no,
least in
that's
the United, yeah. Go ahead.
no, I think that's good to hear, and of course, when it comes to Paralympic athletes, they're willing to take more risk in order to have this high performance. But I do think we need to educate the people that it's really necessary to follow then the guidelines that your guys are stating online, just to make sure we're not getting this wild forest of 3D printed devices, but yeah, that we're really following the right protocol and the right idea behind it. And of course, like in order to have this high performance, you're willing to take the risk. But I do not wish grassroots athletes or just talents that are still developing, trying to use those devices in order to become an athlete quicker, and then something is failing. But it's good that you guys are giving all that information as well. So yeah.
I mean, we are mostly focused on sort of low risk devices right now. So we're not like putting up 3D printing instructions for prosthetic limbs or anything like that. It's mostly just simple adaptations that allow people to participate in different sports and recreation activities. But the goal being that there is a website where at least it's been made, it's been tried, and then here's the instructions, more detailed instructions on how to make it and what test data is available for that device. So I think it's a step in the right direction. And athletes are doing it anyways, and not only athletes. I mean, it's anywhere from school kids to I mean, I was just at an event a few months ago, and the grandfather bought a 3D printer for his grandchildren for for Christmas, and then decided to buy one for himself. It was so much fun, and he was making adaptive sports modifications and adaptations. Um, and so it's just it's part of it's just recognizing that the technology's become affordable for many people, so it's becoming ubiquitous, and people are just going to make things. So it is probably worthwhile to have, I think, two things: having a vetted website, so if you're doing, you can hopefully do them a little more safely. And the other thing is just so And not everybody, people might have access to the machine, but not know the intricacies of making some of these devices.
Yeah.
But I do,
But in
like, for
general,
example, go ahead,
sorry.
Marina.
Yeah, I wanted to add a point about openness. I believe in general, like having an open source models is helping us to collect more data. So if people are testing and giving their new ideas, creativity, and not only in this category, but also in other fields as well. The main advantage of making something open source is to test as widely as possible and to get the data from other users that we don't have access to, which will really help us for the future design process of even not open but commercial models as well for manufacturers.
And the other thing our website allows people to do is put their own comments up and say, "Oh, I made this, but I use this material, and this is how I changed the process a little bit too." So it's a closed loop system. So Ian, I know that in Illinois you guys are making 3D printed racing gloves, right? So
Yep.
can you talk a little bit about that?
I mean, I think the process has evolved over the past 5-10 years, and the gloves, sort of the frame of the glove, is contoured to each athlete's hand, the shape, the anthropometrics of their hand, which is great. And then there's another piece that can be selected based on contact needs, so weather, preference, grip, which just wasn't available back in the day. And so yeah, we're testing now. What materials lend to best contact under what conditions. But boy, what a tricky thing to investigate, right? Talk about asking the right questions and under the right circumstances. And particularly when you're looking at elite level athletes with a perfectly contoured glove with contact surface A versus contact surface B, it's hard to elicit big differences. They look good in both, right? So it takes some real knowledge and know-how to tease out those differences. But the key is now that athletes always have their own file that they can print out a glove whenever they need it, or a part to a glove whenever they need it, where back in the day it was just laborious. So yeah, it's an exciting line.
I mean, I think that the idea that you could have a glove for, hot weather, cold weather, wet weather, dry weather is pretty exciting. Although
Yeah.
that's a pretty challenging engineering problem. Just even people have been studying tires, because they have a similar sort of problem for decades, right? So,
Yeah.
and I don't know about your experience, Ian, but I could tell very small changes in either my push rim or my gloves when I
Oh
was
yeah.
when I was a lead racer, and
Oh yeah.
I would make new gloves um, probably far sooner than well, when I would now. Now I wouldn't worry about it so much, but if but back when I was competing, trying to compete at the highest level or competing at the highest levels, you small changes you would start over again, right? Or you make
Yeah.
make modifications. So
Yeah.
the rigid gloves have a little bit of advantage, I think, that way because the glove doesn't change so much, but the surface changes, and so
Yeah. It
and there
changes your
are
lever. Well, yeah.
yeah. Um, Although you do change your stroke based on the weather conditions. If it is slipping more, then you're going to change your stroke pattern a little bit. It's just like going uphill or downhill, going uphill or flats or slight downgrade in
Yeah.
wheelchair racing. We've also seen the same thing. I know we've been making the cranks or the pedals for hand cycle pedals as well, where we customize those to the individual so you don't have to get as much wrist fatigue from grasping and also challenges with the, also getting your hands to go numb or something for based on how you grasp, push, or even burning the calluses between your fingers, that sort of
Yeah.
thing. And so I think it's really cool that there's a lot of opportunities in those areas. And the materials, for those of you who are not intimately familiar with 3D printing, there are new machines that can print different materials in the same machine. And so so you might have a more of one surface against your skin, and another surface that works against the push ram, or interfaces with another part with the handle of a racket, or a paddle or something like that, where you want to have those different sort of interfaces. One maybe a little stickier or softer, or more compatible with the skin, those sorts of things. So that's those 3D printing technologies. And of course, you can see it, at professional athletes in in the United States and some other countries, where they're 3D printing entire shoes, and to make them extremely well fit on the person's foot, and lightweight, and provide the support and the padding exactly where needed. And I think that type as well. One of the challenges is going to be really exciting to see how that gets into parasport as well. So if you've got, I got athletes that have had limb salvage surgeries, or with cerebral palsy, where they do run, like, to actually make a shoe that meets their physiological and anatomical needs is going to be an interesting future design, both the athletic challenge and design challenge, I think, as well. Rather than, and if you can, the nice thing about CAD models is that you can, like Ian said, you could replicate exactly the same thing, or you can iterate on the same thing. So like, oh, that feels good, but I'd like to, remove a little bit of material here that's bugging me, or can we add a little bit more because I don't feel like there's a good contact. You could do that on the CAD model, and you could keep all these electronic iterations till you get it exactly right. And then that exactly right might also be different whether you're sprinting or you're doing distance running. So you may say, oh, for this one I need this shoe or this insert, and for this other one I can have this shoe or this insert as well. The other thing that's kind of exciting that's happened now is that, up until a couple years ago, you couldn't get true elastomers or rubbers 3D printed. So those materials, they would feel soft, but they would break down after just a few cycles, or a few hundred cycles. So you really weren't useful for for like as padding on a glove, or padding even as a cushion on a wheelchair, some sort of padding on a piece of sports equipment. And that's now changed. Those machines are still a bit expensive, and the materials are expensive, but with time, those prices will likely come down. I think what's exciting is, like, a lot of times, if we use sort of foam to pad different areas, eventually you can sort of replace the foam with probably a 3D printed, breathable, washable material, so that's more compatible with the body as well. It doesn't break down as fast.
Yeah, another thing is smart materials that has a really big potential in assistive devices. Like, again, for example, dielectric elastomers that can be partially 3D printed, but we can use also hybrid technologies with the traditional actuator as well, to make really accessible devices, like both in soft robotics and also in assistive devices. Because what we have, like the challenges we're facing now, and we faced in Arm Bionics developing prosthetic arms, is that current materials are very rigid to have enough flexibility for the degrees of freedom we want to have. The challenges are a bit different for prosthetics and wheelchairs for sure, but I still believe like soft robotics and smart materials development will affect a lot both of the industries.
Yeah, I agree. Actually, other things I think is that it's easy, that's now um, uh, uh, conductive ink, right? So you can actually make the person's own uh, training equipment, training clothing, or the uniform a sensor.
Yeah, yeah, that's really fascinating.
So you could in with chips that are small enough that you could theoretically, just put your shirt on and it would monitor um, muscle activation and heart rate and blood oxygenation and pulse, um, respiration rate, all kinds of things, right during training and during uh, and during competition for that matter, which I think is interesting. Um, Also, so I was going to ask you, I have a couple more questions. I've monitored the audience. So far, they've been pretty quiet. But so, Maureen, do you have any thoughts on how we can democratize 3D printing for adaptive athletes, especially in lower income countries?
Yeah, I guess, but for example, in Armenia, what we did, we had our small laboratory that were using different kinds of printers. And we also are part of engineering city, which is a hub for different engineering companies. And there are some 3D printers that are more like pricey, but they have bigger, better quality. And I guess like if some companies can, like there are some environments that we can share equipments, it's a better way to democratize use of like what the equipments widely. Because for example, our company can use the one machine like few hours or like the whole day during the week, but it cannot be used the whole like all 7 days. But if we're sharing equipment, it's more easy to get access of to equipment and use it. Yeah. Another thing, I guess, is which is already happening, is different opportunities for like grants that are covering equipment for the low-income countries to do R&D. And we'll, for example, in Armenia, we have several 3D printing laboratories already in the research institutions that are using these models, like both, again, in the artificial muscle technology as well. And this is what helps low-income countries, because not all the companies, especially small companies, can access that. And then and there are some low-cost printers that can be accessed even by the individuals. But if we're talking about real R&D and making some products, I think it's important to share the expensive and high quality equipment.
Great. So I see that there are more and more, Marina brought this up, more and more advances in robotics, and that is translating into uh, powered prostheses and powered orthoses as well. Um, and I can see that that's likely to impact the Paralympics at some point or parasport, because what I've seen over my time that I've been involved, we went from things like the Seattle foot, the energy storing foot, which basically was a nylon keel, right? Now to carbon fiber blades, but commercially available, although not yet used for parasport, but are used for some of the others for some other sporting activities, things like powered ankles and powered knees. And I also see pretty exciting. There are FES, functional electrical stimulation, ankle orthoses for like drop foot, right? And also now some pretty sophisticated knee and ankle orthoses, so usually either knee or ankle orthoses that are powered as well. And so do you perceive them ever? I'm curious because as at some point I could see that they supplant the current passive devices. And so when that becomes the norm, could you foresee that impacting parasport at some point? I'll start with you, Alina.
Oh, that's a very difficult question, in my opinion. Because of course you don't want technology taking over performance, and you really want the performance to be key. But of course, if a device would help the movement itself, and make sure less injuries are happening, it perhaps could find a way. But myself, I'm not so much a fan of using more electronic devices within the sports, unless it would all equipment would be equal for every athlete, and I'm not so sure that is going to happen anytime soon. So I think it's a very interesting topic, and I assume that people, their viewpoints would depend on how far their own development would be within this matter.
Yeah, thanks. Ian, do you have any thoughts on that?
Yeah, I mean, similar answer. I think it would be interesting to watch how these technologies evolve in the non-competitive world, everyday world sense, and then kind of extrapolate, make predictions based on that. But yeah, there's lots of potential.
Marina, any thoughts?
Yeah, I will agree. These kind of technologies are not like commercialized a lot, so we don't have enough data to understand the long-term effects and results. So yeah.
Yeah, I agree. It's interesting. I mean, there are always evolution in sport, right? I mean, in the when the Paralympics started in 1948, they're primarily wooden and steel wheelchairs with the large wheels in the front, and now the racing chair and of today shares almost nothing, and it has no common components to the racing chair of 1948. Although, except the fact that they still have wheels, but otherwise, and something to sit in, but otherwise you couldn't tell that they're the same sport. And other sports have evolved in similar ways too. So it'll be an um, interesting challenge. Although even if you look at in the early 1990s, in the seated throwing events, there was no longer required that you threw from a wheelchair. You could just throw from a seat, and that changed the entire sport as well. When the throwing equipment that people use and the performance that people were able to achieve, and now they were able to fit their body as well. So be curious to see. Same thing with prosthetics, going from people starting in the 1940s and 50s using feet made of wood, and then eventually with a solid ankle, cushioned heel, and then to a nylon flexible heel to truly carbon fiber energy storing feet. So I think there's always evolution in sport. It's just a matter of at what speed and sort of where do you draw the line as well, right? And then of course there's always some inequity when there's a transition, because some athletes get access to the newest technology faster than others do, and so that creates an inequity until there's or in that lag time, or until that time till people catch up. Well, I have a couple more questions that I'm going to ask all of you. Maybe I'll start out with Marina, if you could identify one technology that is underutilized or underinvested in right now, but could have an outsized impact on para sport performance or participation in the next 5 years, what would it be?
Um, it's a good question. For if we talk in general for everyone, I guess we're coming back to from what we started. It's data, and the technologies from which we can collect the data, and to be sure we're collecting, as Alan mentioned, the right data, because we can have a lot of data, but the thing is that to understand also how to use this data. So wearables and connected platforms where we can connect both devices, patients, like as a community, and clinicians and manufacturers who can participate in the whole process.
Great, thank you very much. So, Alina, the same question for you. So if you could identify one technology that is underutilized or underinvested right now, but could have outsized impact on parasport performance and participation in the next 5 years, what would it be? Or what would you invest in?
Yeah, so I I think it's a very interesting question, and of course, there's multiple answers to this question. So, what I would be find really interesting, and I've mentioned it a couple of times already in this session, is when it comes to talent development. I mean, we have a lot of potential athletes that are only guided later on in their career, and I would find it very interesting if we can come up with the right technology, the right way of feedback, that those athletes can just be monitored and coached from early stages, because we all know that the coach just around the corner doesn't have the experience needed for this type of individual with this type of disability in this uh, specific sports. So if we can come up with a technology that can help that coach at the club, at the grassroots level, to understand the athlete's load, the athlete's progression, if we can help it try to detect injuries or overuse injuries, or just something that we can make sure that if that athlete really joins the Paralympic program or joins a talent team, it's already further developed than an athlete is at the moment. So I would find it very interesting if we can come up with this. Yeah, perhaps it's something like Marina says, this kind of hub where we can connect each other when it comes to what's the right progression, what's the right load for a certain type of person at a certain type of time within their youth. I would think that will be very interesting how technology can play a part in that.
Yeah, and if I can add something regarding the talent development, what I saw, like in my experience, a lot of role plays their families and the care teams. And I don't see enough space right now or technology that uses this power, but it's a really powerful thing. Some athletes that I saw that had started to train like from their young age, it's because of their parents, because of their family approach, because of the mindset that they had in their families, and also vice versa. I saw amazing people who had lots of potential, but because of the environment they were in, they didn't start it like earlier that they could, because they were afraid, they didn't have a support team, they didn't have tools to do that. Yeah.
That's great. So Ian, same question to you.
Yeah, all great answers. I agree. I mean, some method for people to get appropriate equipment and training sooner, whether that's through modularity, whether it's through something, a technology like Kirigami. But we all see it, the currently the battles that people have to go through to get to a point where they can access great equipment and great technology. If they could get that sooner, right off the bat, a lot of it just has to do with luck and resources. Where's your location? What's around you? And I wish that wasn't such a strong force. I think another side, I don't know that it would necessarily get more people involved, but selfishly, I would love to see better physical activity monitors for perhaps wheelchair using populations, right? Something that you could take with you from your everyday life to a hand cycle, to a racing chair, to whatever that would give you knowledge of energy expenditure, power, stroke frequency, right? Something that's analogous or that mirrors what able-bodied or ambulatory folks have, something close to that. It's a little bit more technical to manage, hand rims, but I find that an interesting topic. But certainly the previous is critical. Finding a way to consolidate all of these amazing resources and get them to the people that need them sooner.
Great, thank you. So I have one last question for each of you. So I'll start with Alina this time, because it's kind of in your area of responsibility. But what role could the Paralympic movement and adaptive athletes themselves play in better setting the research and engineering agenda? And how could we better structure that collaboration?
Yeah, I think that's perhaps one of the most important questions, and I've mentioned that before already, that we are creating these technologies for them, so the question needs to come from them as well. And that's what we're trying to do within the Netherlands now, is that first it was just two worlds. We had the Paralympic programs training and doing their development, doing their innovations, and we had the universities and universities of applied sciences, and sometimes they were in touch with each other, and both worlds would have so much knowledge and so much insight, one from being active in the field and the other from being in academia. And we started the conversation, the mandatory conversation almost, that we really invited the people from the universities into the training setting and really asked the athletes, really asked the coaches, what are the questions that you have? So where do you want to be in 4 years, and what do you need in order to get there? And then once we get a picture of what's going on, then we can go back to the drawing table and try to figure out what technologies we need to develop or what research we need to do, because it starts with the end user and it ends with the end user, and we're somewhere in between. So we cannot do our research or development without the Paralympians. And they have so much useful insights that we cannot think of ourselves because we do not have the experience. So from my perspective, when it comes to setting the agenda, we cannot ask every athlete for their own agenda, but we can collect information from different athletes and put them all together into an agenda, and then try to come up with solutions to those topics. So I think, and that is where our job is, to build that system in order to facilitate the athletes. We do not have to wait for them to come to us. No, we need to go to them and offer them our help, and let them know we're there for them, and then we can create this valuable environment and really develop everything all together, be co-designers of it.
So Marina, so what role should or could Paralympic and adaptive athletes themselves play in setting the research and engineering agenda, and how do we do that better?
Yeah. So what we're building at Connectra is kind of meant to have this connection with the end user, as Ellen mentioned. So our main, we're targeting the end users to understand them and collect the data from them. So, but they are giving their consent to have the anonymized data, which we can use for both research perspective, improving manufacturing, improving the outcomes from the clinician's perspective. I guess the main thing is that, like, the data is very sensitive thing, and the main thing is how we can make the environment safe and have the all compliances, HIPAA compliances and everything, so they will feel safe to provide the data of their usage, so we can use this data to give better products, better solutions to them. I guess this is the right way to do it. And another thing is to constantly having interviews, talk with them, because even if we have the data, but we're losing the real connection of talking with them, including them in the process, what we're building, what we're researching, we still have a gap, because data sometimes, so that's why we're trying to use different types of data, both the device data, usage data, behavioral data, but still, we need to include questionnaires in the apps that we're using. We need to have, again, if even it's not an interview format, some kind of live communication. So the main 2 points that I'm trying to highlight is data and real feedback from them.
Thank you, Marina. So Ian, the same question to you.
Yeah, agreed. I mean, I think just a more formalized process of ensuring that dialogue, right? I mean, the athletes and coaches have no shortage of things to say about needs regarding their sport or their equipment. We just need to hear those needs, and the process needs to be formalized so that it doesn't amount to luck, or it doesn't amount to chance. It doesn't amount to a team being close or connected with a particular university, right? So if we can formalize that, the stream of voices, I think that would be super beneficial to everyone.
Great. Thank you. Thank you all three for those answers. We're just about to wrap up. So I'd like to just ask each of you, and we'll start with you, Ian, if you just have any closing comments.
No, I think that technology and information is so rapidly evolving that we've got to be careful that we keep track of it, organize it, and make sure that the parties who can benefit get the right information and have the guidance to use it safely and correctly. And I think that's in part one reason why we're here today. But it is exciting times, but we need to be careful.
Marina, any final comments from you?
Yeah, I'm actually really excited to see how it all goes, and I'm very happy to see this kind of conversations because, for example, for a few years ago, I think both the clinicians and maybe I saw a lot of interest from researchers previously as well, but now we see understanding from the manufacturers and clinician sides as well, which is very important. And this kind of conversations leads to finding the right solutions. And I'm happy we talked about the very important points of having the unified hub, having everyone in one place, and having a neutral space to do that. Because what I saw that was not working was that the fragmentation part. Each manufacturer or each lab has their own projects for sure, but we need to find a way to make the benefit and impact for the whole industry, which will affect all. So it's a win-win. If we can do that and create this natural space, we'll all win. Yeah.
Elina, we'll let you provide the final comments.
Yeah, I mean, I totally agree with what Ian and what Marina say, and that's something that I noticed in the Netherlands as well. At first, when it came to creating new technologies or new innovations, we're not really working together. But once we started working together, we realized that we can benefit from each other's knowledge and together come up with even better ideas, and it also even being more cost effective. So yes, within a country is very important, but also when it comes to this global world that we're all living in. So I'm very glad that we could still have this session online, and we need to keep continuing sharing our knowledge, because we know a lot all together. And of course, there's, when it comes to Paralympic sports, there is this competition in it. But yeah, the general things, that they all stay the same. And if we can help each other on those general parts and make it more accessible for the people that we're doing it for, I think in the end, that's the biggest goal that we have. And that is more athletes or more people doing adaptive sports, and more people doing it in a safe and happy and good environment. So yeah, we need to keep on sharing our insights here.
Well, thank you all for being the panelists today. I enjoyed your insights and your comments, and appreciated and your contributions to the Paralympic movement. I'd like to thank all of the participants today for joining us and joining us live. And remember that we have 3 more sessions coming up, so if you have the opportunity, please participate in them. They will also be recorded and posted on our website. So thank you, everyone, and have a good day.
Thank you very much.
Thank you. Thanks.